Hey guys, welcome to another video. So today, another question in the nice question series. Today's question comes from the Extension 2 syllabus. The question actually comes from Normanhurst Boys 2024 trial paper. Now, it's 10 marks, guys, 10 marks. It's the final question in the Normanhurst paper. So look, if you were sitting this test and you couldn't do 10 marks, I mean, that is damning, right? So the question itself actually isn't that bad. So make sure you can do something like this. It's integration related, so not too bad. I thought it was a nice question. So here we go. Now, before I dive in, as always, if you like the video so far, subscribe to the channel, like the videos, and tell your friends. Guys, let's dive right in now. All right. So Normanhurst boys, let's have a look. So the diagram shows this graph, right? Which looks like a sine curve, but because it's multiplied by e minus x, which is slowly going to 0, it's sort of wavelength sort of down to the amplitude sort of decreases every time you go about the wavelength, right? So, okay, pretty straightforward so far. All right, the question, show that this integral here looks like it's a by parts question. Wow, 3 marks, that's generous. Oh, because it's e minus x, so that's got recurrence, okay, but still pretty easy. 3 marks, I think it's a bit generous. And then it goes, the terms A1 now, okay, they represent successive areas above the x-axis. So they've defined A1, A2 as the area sort of above the curve only, so they ignored the bottom, okay, that's important. Okay, and bound by that, okay, the area there, area AN is bound by these limits, okay. Areas A1 and 2 shown, okay, show that, okay, cool. Yeah, show that AN, okay, so I'm just gonna have to sub those limits into the integral. Okay, that's pretty straightforward, I think. Show that is a geometric series, okay, so geometric series typified by having a common ratio or common multiple, yeah? And limits, okay, not too bad. And then when n goes to infinity, so given that n is a half, find exact, okay, cool. Not too bad, right? So, okay, let's get started, right? All right. So, part one. Now, we know it's recursive. For those that know exponential multiplied by trig, that's a infinite looping by parts if you keep going. So we need to cut it off, right? So we need to let in, also I in this case, equal to the integral. Yeah, of e minus x sine x, right? And we have to go by parts twice, right? For those that know how to do this. So we go let u equal to, now y8, right? Y8 says sine first, so sine x, right? And then dv equal to e minus x dx. Yep. And then du equal to differentiate it, that's positive dx. And this will integrate that, so it's negative e minus x. Yeah. Therefore, I equals to uv, so minus e minus x sine x. And then minus, that's a plus, right? Because one's subbed in. Integral of e minus x cos x dx. And you can see there, need to by parts out again, right? So same deal here, let u equal to cos x and let dv equal to e minus x dx. Yeah, du negative sine x dx and v equal to negative e minus x, right? I'm going pretty fast about this because I think it's pretty straightforward, right? For those that know how to do this question in recurrence, just be careful, right? Because when you do this, right, you just got to know to let it be I because the recurrence keeps looping, right? EX and trig, it keeps looping. So, you know, keeps looping. So then equals minus e minus x sine x. Plus now, just for the by parts bit, it's uv minus e minus cos. And then minus times minus, plus then minus e minus x. Oh, sorry. X dx. Cool. And then you basically spot immediately, right? I was the original. and that's the original there, right? So then let that be I, right? Let that be I. Then you get, therefore, I equals 2 minus E minus X sin X minus E X cos X and minus I. Yep, group your I's, right? Bring the I's together. So bring that I over so you get 2 I's. Sorry, I keep using pink eye. Equals 2, and maybe factorize negative E minus X sin X plus cos X. And then divide by 2. Therefore, yep, I, which is the integral of E minus, yes, so sub that back in, equals to negative E minus X on 2 outside of sin X. Or should I just put it? So they want me to actually put negative half, okay. So the question itself says, can you please state it like this? So I'll do the same. E minus X sin X plus cos X. Let's see. Why not? Okay. Guys, that's 3 marks, right? So this is the last question in the trial paper for Normanhurst, but it's not that bad, right? It's not that bad. Yeah. Well, at least the 3 marks to start with, it's not that bad. So move that up. Get some space. Okay. What's part B all about? Part B is basically trying to get me to sub in the limits. Okay. So cool. Now there's only one catch when you're subbing in these limits, and I'll show you what it is, right? So part 2. So AN is when you sub in the limit into the integral. Now, what were the limits? It's 2n minus 2 pi. And was it 2n minus 1? Yep. 2n minus 1 pi into e minus x sine x dx. Because I've already integrated that, I'm just going to sub it into the integral. Right, so it becomes negative half e minus x sine x plus cos x. Yep, and 2n minus 1 pi, 2n minus 2 pi. All right, now, because I'm subbing in these limits, right, into sine and cos, these two limits in sine and cos, might be worthwhile just off to the side note. Yep, when I sub in the top one, now, 2n minus 1 pi, 2n minus 1, n is an integer, isn't it? It's defined as an integer, yep. So that must be odd, right? So this element here is odd, right? That's odd. So any odd pi's, when I sub it into sine and cos, right? So for example, so for this one, sine x, yeah, sine of any odd pi, right, would be like, example, sine pi, sine 3 pi, etc., right? They're all zeros, right? Yeah, sine pi, because of the repetitive nature of it, it's all zeros. And similarly, cos x, for example, cos pi, cos 3 pi, right? What's that on the cos graph? It's all negative ones. Yeah, so when I sub in that limit into there, sine 0, cos is negative 1, right? Keep that in mind. And then similarly, 2n minus 2 pi. This guy here is always even, right? This guy here is always even. So when I sub that in to sine x, so for example, sine 2 pi, sine 4 pi, right? They're all zeros again, right? Because, yeah. And then for cos x, so for example, cos 2 pi, cos 4 pi. What's that? Full wavelength, that's that 1, right? Yeah. All right, now let's sub it in. So then, therefore, an equals 2. Yeah, so it'd be like, I'll take it in negative half, right? That'll be e sub in negative 2n minus 1 pi, multiplied by now the sine x is 0, and the cos x, so plus is minus 1, and then minus e. Sub in the bottom limit now, right? Sub in the bottom limit, this one here. And you get negative 2n minus 2 pi multiplied by sine is 0 and cos is 1. I'm just going to have a quick look at what I have to prove. Okay, I'm gonna put a negative there, so everything's negative, so the negative multiplies that. Cool. Half, and they switch to, okay, too easy. Wait, let me just make sure they switch both. Yep, they switch too easy. Okay. So all they've done is that, see how this becomes negative 1, right? That becomes negative 1. So that becomes negative 1. So then all the negatives, right? 1, 2, and 3 becomes positive, so it becomes positive half, and then they swap the direction of the brackets. So therefore, an equals to half e 1 minus 2n pi plus e 2 minus 2n pi, which is my final answer. I think. Let's have a quick look. Boom. Nice. Yep, not too bad. Guys, how's that so far? Not too bad? Yeah. So that's 5 marks. Right. Now, let's do the second 5 marks. So let's see. Just tell me now. Part 3 says, can you please show that it's a geometric series? So I need to show that there's a common ratio. FYI, for those that are looking at this paper and you go to the solutions, they actually forgot to do this, right? They just basically went and did the second part. They didn't actually prove that there's a common ratio and hence has a geometric, is a geometric series. Put that, and then that is a limiting sum. Okay, cool. So part 3. Now, part 3 is about establishing a pattern to sort of demonstrate that it is a geometric series, right? So let's go A1. Now, I'm just going to sub numbers into this expression, right? So sub numbers into that expression there. So sub a when n equals 1, you get half e when n equals 1. N equals 1, that's minus 1, so that's like e minus pi plus n equals 1. N equals 1, is that 0? No, this is 1. Yep, that's a1. A2, what does that give me? When n equals 2, that's e minus 3 pi plus when e is 2, that's negative 2. Yeah. Let's do A3, right? Let's establish a pattern. Oops. When n equals 3, that's e minus 5 pi plus e minus 4 pi. All right, and so on and so forth, right? Now I'm hoping that if I take, so 4 GP, right? I need the ratio of A3 on A2. Also maybe we'll go A2 on A1. Yeah, equal to A3 on A2, right? That's what I want. So now A2 on A1 equals to half e minus 3 pi plus e minus 2 pi all over half e minus pi plus 1. Obviously, the halves go away. And I'll try to factorize from the top, maybe just e 2 pi or negative 2 pi. If I take that out there, that's like e minus pi plus 1, which is good, because once again, that cancels out. And that gives me my common ratio to be e minus 2 pi. Yeah, e minus 2 pi. Is that right? Yeah, I think so. Wait a second. Common ratio. I think I've done something right. I think I've done something right. They're saying that the common ratio is e minus pi. Ooh. Not sure about that e minus pi. Did I do it wrong? Did I do something wrong? Why is the answers saying this forms a geometric series? Oh. Oh, I see what they've done. Oh, okay, got it. So they've not done the G. Okay. I'll show you what they've done. Actually, so I take that back. They did do this right. So what they've done is before instead of calling this is term 1, term 2, term 3, right? Actually, let me finish up what I'm doing, and then I'll show you what the answers did. Okay, it's the same concept. Oh, actually, no. Let me go with what the answers say because they basically establish. Um, yeah, I think we get the same answer. Okay. So what the answers did, right? So what the answers did is basically instead of calling this as term 1, term 2, term 3, they said, okay, once that's A1, A2, A3, they go A1 plus A2 plus A3, right? Dot, 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 equals to 1 plus E minus pi plus E minus 2 pi, right? Plus E minus 3 pi, etc., which is a GP where A is 1, R is E minus pi, and N is, well, don't need N, right? Just need those two, right? Yep. So that's actually it's probably faster. Maybe I'll just do it that way, right? Because then they don't have to sort of divide. Yeah. So they basically just rewrote the expression and said, instead of calling it term 1, term 2, term 3, they just said, I'm just going to lay out the expression and then it's a GP, right? So, and then they said that. Perfect. Right? Great. Now, that's the GP. So limiting sum, we know the formula is A1 plus R. So then quite simply, it'll be 1 on 1 plus E minus pi. And is that what they want, or do they want me to simplify? Okay. Now, so they divided it by 2 because there's some. So let me see what they did, right? Yeah, this is why the method that I had before was right. So this is summing it all up. Why did they divide this by 2? This forms the sum of the series. This is right? So if I rationalize this, why is there an extra 2 there? Why is there a 2 there? They got the limiting sum to be that. And then they halved it. AN equals to a half. Oh, sorry. My bad. The reason why it's halved is because when they sum this, there's like, see all these halves here? Yeah, okay, cool. Yeah, perfect. So therefore, you get that. So I should really go, oops. So I just put a little half in front of all of these. So it's like a half multiplied by that. Because the GP is just this bit, right? Yeah, that's the GP, yeah, which is this bit and this bit. Yeah, cool. So then that becomes half. Now, I think they just made it into positive. So then they common denominated that, or times everything by E pi. You get E pi plus 1. Is that what they want? So we'll look. Perfect. We're done. Yeah, therefore, limiting sum is E pi on 2 E pi plus 1. Guys, so the GP isn't hard, right? You basically just establish it, express it as an expression where it grows by E negative pi, right? Which is the common ratio. The limiting sum isn't hard as well. My apologies there that I forgot the half there. Still pretty easy, hopefully. part 3. Guys, nothing I've done really is that intense so far. Part 4 is it? So let's have a look. Now, part 4, what's that saying? So I'm 8 marks in, right? So the last 2 marks. So I'm given that when n goes to infinity, the whole expression goes to 2. Find the exact value. Okay. So let's see. Part 4. So part 4 says the limit as n goes to infinity of the integral, between 0 and n of e minus x sine x dx equals to a half. Okay. So that's saying that when I integrate from 0, and this expression here, see how there's no allowance for the positives only, right? Because right now I'm given that the positives only, right, gives me this limiting sum. But this integral basically sums both positives and negatives, right? And negative areas, right? So what I'm gonna do, I'm gonna go yeah, let's see, let x equal to sum of areas above x-axis. Let y equal to sum of area below x-axis. So I know that the sum of x is what I found, right? That's upstairs as this guy, right? So just be clear, that's x, and y are basically all the negative areas, right? And together they add to half, right? Therefore, x plus y equals to a half, and I can make y the subject, right? Because I can go, hop this into x, right? Now, why do I want x and y? Because if you think about what I'm trying to find the absolute value, right? Absolute value basically in terms of x and y just equals to x plus y, because any negative area just comes upstairs, right? And becomes positive. So when I don't have the absolute value, that's like trying to find all the greens minus the pinks. But when there's absolute value, it's like trying to find all the x's, all the greens plus the pink, right? So but I already got x, and from this subbing into that expression, I can find y, and then I can find x plus y, right? So let's sub that in. So I got, what's that? E pi on 2e pi plus 1. Oops. Plus pi, y equals a half. Y, bring that over. Minus e pi. Sorry, I left a bit of space so I can common denominator, right? I can go multiply this by so I can times top by e pi plus 1 and e pi plus 1. Let's see if I can simplify that. So that's now all over 2 e pi plus 1. Expand it to that, and e pi, that's just 1. Is that it? That's nice. Yeah. Now that I have that, therefore, yeah, in terms of absolute value terms, right? Oops, I did that wrong. I should say e minus y. Oh, silly, right? So this is minus. I wonder if that does change things. Because then if that was minus, then it'll be this minus half. Okay, so it'll be like that. Sorry, bit lazy. Ideally, that minus is right. Yep. So what does that change? So then when I comment on it, it'll be, oh, that still goes away. Maybe it just becomes minus 1. Okay. Let me just check that. Y is equal to, wait. What's going on here? I've done something wrong. That's not a plus here. Oh, the formula's wrong. Silly Billy. Guys, I'm doing all the basic stuff wrong. That should be minus. These guys are all minuses, right? So make sure you capture that, please. That's the formula. That's a formula. That's a minus. Let me just check. That's what I had to prove, right? Should have seen it. Yes. Okay. Yeah. Okay. So what does that change? Let's see. Changes that. Changes that. Changes this. Changes. Okay. Cool. Might change that. So let's see. That's minus. That's minus. This blue part is -1, -1, and then I had it right. So in a big round circle, I got back to what I was trying to find in the first place. Sorry, but the bottom was minus. So semi difference. Okay, cool. Okay. Now that I got x and now that I have y, therefore x plus y is equal to e pi on 2 e pi minus 1 plus 1 on 2 e pi minus 1, which gets us to e pi plus 1 on 2 e pi minus 1. Is that my answer? Oh, they didn't give me that, but that is my answer. Guys, how was that? So if that was okay, that was 10 marks in Normanhurst boys' final question in a trial paper. Hopefully that was okay, guys. Let's leave it there. If you like that, like the video, subscribe to the channel, and tell your friends. Thank you very much.